Right, hello, welcome to a new video. So today we're going to do this problem called binary search. It's a LeetCode problem. It's an easy LeetCode problem, number 704. And we're going to solve this problem using my solution process that I do. So first off, I read over the problem and we get the input and output from it. I read it a couple times to make sure I do understand the problem and what I want to do. And then afterwards, I would like to ask some questions if I have any, of some constraints or some issues. And then I would like to go over some examples once I understand the input and output, right? And once I done some examples that showcase that I do understand the problem, I'm safe to say that I can go ahead and make some approaches that I can use to solve the problem. And then once I find an approach that I can actually do and is probably optimal, I like to plan that approach and then implement that approach and then review that approach once I'm done implementing. So yeah, so that's the roadmap that we're going to do. So let's go ahead and start. So first off, let's just go ahead and read the problem. So given in a hold it. All right, it's so bright in my room, but I can't read it. Okay, so given an array of integers, nums, which is sorted in ascending order and an integer target. Write a function to search targets in nums. If target exists, then return its index, otherwise return -1. Okay, so from what I got from it is that our input is going to be two things. It's going to be an array nums, and an integer targets, right? And then for our output, we're supposed to return an integer in general, but that integer is supposed to represent, yeah, but the integer is supposed to represent the index where we found nums, targets in nums, or -1 if not find targets in nums, right? So yeah, that's pretty much the input and output. And then for some questions, I don't have any. We know that it's in ascending order, so I'm going to take the note. So I'm pretty sure if this was an interview, they wouldn't say like, but your problem is binary search. They'll probably be like, okay, so find this number in the list, right? They wouldn't say the name of the problem, right? Because that would be kind of stupid. So I'm gonna assume that this is what they're gonna give me. It's like, okay, you have an array and a target, then you're supposed to find targets within nums and just do that, right? So some notes is that I would have to say is for some questions I would be like, is this list in ascending order? I probably wouldn't say ascending because I'll probably be stumped. I'll probably say, is it in least to greatest or something like that? So is the list in ascending order, which is basically least to greatest, right? They'll probably say, yeah. Or like I can say like, can we assume? Like, can we assume? Like, yeah, sure, why not? And then just like to like ask a question, just ask a question. Even though I know it's in ascending order, I'll be like, um, will there be any negative numbers in this list? Honestly, this question is a question just to ask a question, just to ask a question. Right? Because again, I said it's in ascending order, so like it doesn't really matter if there's negative numbers in it. But I'll just say yeah. Right. And so now that we know this, we can make the most optimal solution. Um, as I studied before, only for like a day, we can make some approaches, such as we can just go through a for loop, go through, iterate through list of n, or we can iterate through list n log n. Is binary search n log n? I think it is n log n. So that's basically binary search. And the O of n, iterate through the list O of n, that is naive for loop, right? So those are the approaches that we can do. So, or match approaches we can do. So I think I'm gonna go with this binary search because it is most optimal. In my opinion, although it's not easier, it is most optimal, but it could be easier if you've done it a lot, right? But for me, I haven't done it a lot, so I can maybe stump on this a little bit. But we're doing it raw, so whatever, right? Doesn't really matter as long as you're learning. So let's make a plan for this approach. Binary search. So what I want to do first in this code is I want to get user input. So get user inputs. I can do that by saying like input user input is equal to integer input of target. Oops. Oh yeah, I forgot. I'm kind of tired right now. I haven't ate my breakfast at all. Okay, so I'm going to get the array of nums. So user array is equal to input. I'm going to put it into a list, basically. And then this is all pseudocode, so and then target, which I'm going to say user tar is equal to it. Right, so we get user input. And then now what I want to do is I want to go through binary search. So I want to search for target in array. So to do that, I can just say I need to do a while loop with binary search. So in order to do that, I need to actually um, initialize left and right. So I can say that left, right is equal to 0, and then the length of the array minus 1, right? And for binary search, I can just say while left is less than right. I'm pretty sure it's less than equal to, but we'll see. Well, in general, it's less than equal to right, right? Um, we're going to calculate middle, so calc middle, and then to calculate middle, we can just say this. We can say mid is equal to, make sure we have parentheses, left plus right divided by 2. I would say divided by 2, like two division signs because we want it to be an integer. We don't want it to be a float. So we're doing integer division. And then we can say if, so now that we calculate mid, we can check if the index value of mid is equal to, less than, or more than the target. But first off, let's do the middle is equal to. So if check if mid is equal, less, or more than targets. So just say check if mid index value. Okay, so I can say if mid val is equal to target, then we're going to turn mid. But else if mid val is less than target, then we're going to want to yeah, if it's less than target, then that means we um want to search to the right of it. So left is going to be equal to mid plus 1. Um, else mid val is more than target, then that means that the middle is more than it. It's so if we want to search the right side, I mean the left side more, so we need to shift the right to the left minus 1. And then we will repeat that. But if we don't find middle at all within this while loop, then we are going to return -1, and we said that if not found, targets in while loop return missing, right? We say that by returning -1 according to the problem statement, right? So this plan seems like it could work. We can go through some visual examples, but I feel like that's okay. We can maybe go through some visual examples if my process is wrong. So first off, I'm going to create a main function, which will be our driver code. I'm going to run the driver code in the file itself. Then I'm going to create a function called find target. Then it's going to take in two arguments, such as the array and target. I think the array should be called nums just for LeetCode's sake. Oh my god. Okay, anyways. So I'm going to pass this for now so it looks clean. Then within my main driver function, I'm going to continue with our plan, which was to get user input. So I'm going to say, first off, I'm going to get the array. So user array is going to be equal to input dot split. I'm going to put that in an array itself and say elements, but for elements for elements in there, we're going to turn them into integers, typecast it into integers. There we go, we get the user array, and then we can say user target is equal to integer. We're going to make that input into an integer. And once you have the input, let's go call find target, and then give the arguments of user array and user target. And then I know that find target's gonna return an integer value, so why not just print it out, right? Test casing. And so I'm really tired. I'm not tired, I'm just like not ready. My morning's not already started. So we're gonna find a target, right? So let's go follow my plan. So first off, let's go initialize left and right pointers. So left and right are going to equal to 0 and respectively the length of the nums array minus 1. And then let's go through a while loop. So while left is less than right. Oh, that sounds so good. We're going to do binary search. Okay, so when we do binary search, we're supposed to calculate the middle. So mid is equal to left plus right with parentheses, because that's really important. And then we're going to check if mid index value is equal, less than, or more than target. So if nums at mid is equal to target, then we're going to, oops, what did I do? Then we're going to return mid. I did it again. But else, then if that value is less than target, then we know that we need to look towards the right side. So we have to shift our left towards the right. F is equal to mid plus 1. Else, where the mid value is more than, then we need to move the right to the left. Let me look at it just to make sure. So mid, that's the target. Okay, yeah. Else, we can just return -1. So this makes sense. Yeah, this makes sense. Like it could work. I'm not sure about this less than. It could be less than equal to. Um, it could be less than equal to. I'm not sure. Does that make sense? It could be less than equal to. But either way, I'm going to run this with some examples. Oh, I forgot to go through some examples. Okay, so let's make some examples right now, right? Because we're about to test it. Examples. So let's say our input, it's going to be an array of 1, 2, and 3, and then let's say our target is equal to 2, right? So it's the middle basically. So our output's going to return the index of 2, which is 1. And let's do some examples that will not work. So 2, our input is 1, 2, 3 again, but our target is 0. Like we're 0, right? So it's going to output -1 because 0 is not in the list. Let's do another example. 3, same input, but different target. So inputs 1, 2, and 3, and our target is 1. It's gonna output index 0 because that's where the value 1 is in the array. So now that we have some test cases and we know what they're gonna be like in the output, let's go run it in our code to see if it's actually the same. So let's say we have the input of 1, 2, and 3, and our target is 2, which will return 1. That's good. Okay. So what about the same array, but our target is 0, -1, that's good. Same array, but target is now 1. Oh, okay. That didn't work. So how come that didn't work? Let's go through it with some drawings, right? Okay, so let's go through it with some drawings. We got paint up. Okay, so we have 1, 2, and 3. So in this point in our code, left is equal to here, right's right here. The middle's calculated to left plus right. So 0 plus 2, that's 3 divided by 2, that's 1. So middle's right here. And we're like, okay, so if mid is equal to target, which is not return mid, so we don't go through that. Our target is equal to 1, by the way. So 2 is more than target. So since it's more than target, we need to make our sliding window less. So we're going to move right to middle -1. Yeah, so right would be right here now. Yeah. And then, okay, yeah, so I'm pretty sure we need to do less than equal to, right? Or we can just say, or we can say, no, we can do that. I'm pretty sure. But I'm pretty sure there's like a case where we can say like, what you call it, like return left or something. I'm pretty sure. I forgot. I forgot. Yeah, but I'm gonna try this out. Um, so 1, 2, 3, 0. Okay. 1, 2, 3, but with 2. Okay. 1, 2, 3, but with 1. Okay, cool. So it does work. It's less than equal to because I forgot about that case where it can be where left and right can be exactly on the same point, and that's where calculate the middle, and that's where they find the target, right? So I'm pretty sure this works. I could try it with more test cases, but I would like to let LeetCode do that for me. So let's go try it out. Boom. So try it out. Let's go run it. Hopefully it passes. Good passes. And it runs. Awesome. Only beats 47%. It's interesting because my binary search is pretty okay, but I think that's because I didn't return left. But I think that's fine. Like, I feel like if I don't say that, like, it makes the code cleaner. Like, it just makes sense. Right? If I say return left, maybe someone who doesn't know code is gonna be like, why return left? Like, why? 'Cause, if you just read it, you can, like, say, okay, so we're definitely gonna find mid at, like, any point. Definitely. So it makes sense to return mid, like in this if statement. But I know somewhere it's gonna say like return left, and they're gonna be like, why return left if like we're gonna turn the mid index, right? So I think this code's clean in my defense. Um, so yeah. To review this, on time it is O of n log n because we're using binary search to iterate through the list. As we do binary search, we're skipping like half of the list each iteration. So yeah, and for space, this is O of 1. We're only using pointers, or we're only using constant variables to help us solve this problem. So yeah,